Sorry, guys. Oh, okay. Yeah, sorry. It happens. This happens to be exactly the same number of slides as that introduction one, so it confused the hell out of me because basically the front slide is the same. So, hi, I'm David Allen from Quantum Mobile Solutions, my little company. And what we're going to talk about today is custom renderers. And hopefully this will be like the first in maybe a series of 3 or 4 talks we want to do over the next few months on custom renderers. I'm trying to get Mike to do one on. So one of the issues we have with using custom renderers is that there's not much documentation out there on them. There's not much in the way of examples. And what there is, at least the ones that Xamarin provide, are pretty simplistic. So they're they'll show you, oh look, we'll change the color of some text on each device and that sort of thing. But they don't actually show you anything that's realistically useful in a real world situation. We'd like to address that for you. So let's talk about how Xamarin.Forms does its layout. Well, basically, Forms uses platform-specific classes called renderers, right, to draw or render the various layouts, the views, the controls, and everything that are provided in Xamarin.Forms. And these things, they calculate the size, position information, using native features for the layouts on the native platforms, and then map their abstract forms representation onto the native platform-specific version of it. Now, they have exposed some of these renderers to developers, and some of the properties in there, and some of the methods in there. So you can create your own versions. And so what this allows you to do is create your own components that are either extend or completely new components from within Forms, and create your platform-specific version. So you can make much more sophisticated controls that are much more like the real-world controls that you actually want to use in your app. In fact, with there's one or two limitations, especially in the Android world, because Forms doesn't uses a single activity, and basically effectively each screen or each page is a separate view that it swaps in and out, rather than using fragments and activities. You can basically recreate just about any control or layout that you can using the native SDK or Xamarin Classic, as it tends to get called, within the Forms environment. Of course, the question is, if you happen to do that on every page, is it really worth going through the hassle of using forms and form structure? Why not just use Xamarin Classic? And that's something you have to sort of weigh up as to whether you want to do that, but you could if you want. So whereas Xamarin often turn around and say they try and promote Forms as something that's really only for prototyping or very simple apps, the reality is it's capable of far, far more, but they don't want to promote it yet in that light, because they haven't basically built up a team that's big enough to support the sort of inquiries and feedback and requests they're going to get if they promote it that way. But it is capable of doing it. So, what is the Forms rendering model? Well, basically, it takes two objects to visualize and control: the element and the renderer. So the element, and this is their terminology, and if you're going to use it, you sort of have to get used to that. So an element abstractly describes the visual elements within Xamarin.Forms. So it's their abstract representation. So in this case, it's a label, and Xamarin.Forms label has things like text color, font, and things like that. And then what happens is it will render that for each platform. So there's a renderer for each platform, and that basically gets mapped onto that based on what platforms it's on. So the label renderer in iOS actually renders it as a UI label. In Android, it renders it as a text view, and in Windows Phone, it renders it as a text block. And that's basically it. That's basically as simple as it is. Of course, it's a little bit more complicated than that, but you know, the concept's pretty simple. Now, there's a number of renderers already built into Forms, which are used to implement the abstract forms that are already there, visual elements, the pages, the controls, as I've mentioned. Most of these inherit from 3 developer accessible renderer classes: visual element renderer, view renderer, and view cell renderer. Okay, now, some, though, don't. They'll say that they do, but they actually don't. They actually inherit from some protected internal renderer classes, such as visual element renderer -2, there's a -1, and these are sort of have elements of them. So if you look at something like view renderer actually inherits from, I believe, view renderer -1, which actually inherits from visual element renderer -1, and these are that little dash indicates that it's private within the Xamarin.Forms space, and that you don't have access to it unless you use reflection. Now, the cell renderer, view cell renderers, and cell renderers are basically a special case. That's a special case. It really is a holder of views rather than actually something that does rendering itself. It basically acts as a way to hold something that's going to do the rendering. So you find that its inheritance is different. It actually inherits directly from object. And the cell renderers are used to derive to define item templates that are going to be used in list views and grid views and table views and things like that. So, why do you want to use custom renderers? Well, creating your own renderers allows you access to the Xamarin.Forms rendering architecture at a much lower level than through the standard components. And as I mentioned, you can duplicate almost any platform-specific visual element or behavior and access it within Forms. However, you'll still need to fully decide how to keep the look and feel, the features, and the behaviors consistent across the platforms you're supporting. You know, if you've got a feature that's available in iOS and it's going to do something, you're going to need something in Android, and if you're supporting Windows Phone, to keep the experience relatively similar and consistent across all the platforms. Otherwise, it's not really worth using Forms. And you're also going to need to be familiar with how to code the control for each of the platforms, as you're going to be writing native code. Because in these custom renderers, you're basically writing Xamarin Classic native code for each of the platforms. So whereas using Forms and the elements, the visual elements that they provide as part of Forms allows you to almost not quite forget, but forget a lot of the UI aspects of each of the platforms. As soon as you start doing anything more complex than that, and you're having to get into actually writing custom renderers, you're going to actually need to understand how those platforms actually construct and run their UIs. And one thing to remember is your custom renderer can inherit from any accessible built-in renderer. So there's 2 main types when you're going to do that. One would be to create completely new custom controls and elements. So maybe you want to have charts or dials or calendars, or you want tiles. You want to do a version of the Windows Live tile that's available on iOS and Android as well, or something similar. Or you want some sort of selector that isn't really supported in any of the platforms. Then you could you'd create a completely new custom control and elements and the associated renderer. And the second case for using it is when you want to enhance existing controls and elements. Say you want to take something that they've already provided and add some decorations to it, things like shadows, or you want to add rounded edges, or you want to customize the behavior so that it behaves slightly differently to the current default solution. Or maybe you want to add some platform-specific features. maybe you want to say, well, for this, I'm going to add some specific features that iOS supports for the iOS version, that Android supports the Android version, and Windows supports for the Windows version. So it's actually even more, tailored to each of the platforms, but even further. So this is the process. How do you go about doing this? Well, the first thing you're going to do is you create your generic Xamarin.Forms element. Okay, it can be new. It can inherit from an existing element. It could override, and in either case, it's going to be overriding existing properties, and it's going to potentially add properties. So override existing methods and properties, and you can add properties. Then you're going to create a renderer, a custom renderer for each of the platforms you're going to support, whether it's iOS, Android, or Windows Phone. And that's going to inherit from an existing renderer. And then you're going to need to register that renderer for that element. And what that does is it actually ties the two together, compilation. When the app is instantiated initially, when it loads up, it will actually go through and say, hey, when I see this element type, I see this visual element object, your custom forms object, I know which renderer to use, your custom renderer to use, in order to actually implement it. So a couple of things. View renderer is usually used as the default rendering to inherit from if there's not a suitable control renderer to inherit from, that's built into Forms. It's sort of the default. It's not always the one to use. Sometimes you'll use visual element renderer. If there's certain aspects for performance, sometimes you'll do that. But generally speaking, if you're doing a brand new control, which doesn't really relate directly to one of the existing renderers, then you'll end up using the view renderer. So any renderer based upon the visual element renderer or any of the renderers derived from it always exposes the following properties and methods. And often these are the ones that you're going to be using if you're going to be deriving from view renderer or visual element renderer. It'll have the element property. The element property exposes the abstract Xamarin.Forms element that you've created for this. Visual element renderer also exposes a draw method, which is the native method that gets called on the platform to actually draw on the screen. And it also exposes the on-element property changed method. And what that does is that monitors the any bindable properties, or any properties that you have in your forms control. And if a property changes a value, it's going to call that method automatically in the renderer. So if you override that, you can actually change the values of the controls. You can call, draw, and change things again. Now, anything based on view renderer, so I separate them out, exposes these methods. So it's going to expose element again, which is exactly the same thing. It also exposes a control property. And the control property exposes the native control element. So the element within your renderer that's actually going to be drawn on the screen. So typically it will be something like UI view or a grid element or something like that. It also exposes the on-element change. I forgot to put the parameters in there, sorry guys. And what that does is when it's first created, that gets called. So in the on-element change, you override that inside there in the custom renderer. You will actually specify, how you create that native element, and then you assign it as a native element, and then it will draw it for you. And then again, there's the on-element property changed method is available. So this is a list of, this will be available on through the Meetup website. But this is a list of the current renderers that are accessible to you. You've got the base ones, you've got page ones here. Some of them, unfortunately, they haven't unified the naming convention of some of them. They've tried to a bit. Jason Smith recently posted, in response to someone mentioning this, posted that, hey, he didn't want to do it because it would break things. I happen to disagree with that, because he could easily, for example, say, instead of having navigation page renderer and navigation renderer, just make it navigation page renderer for all of the platforms, but also have one called navigation renderer that just inherits on it. So it's just there as something to keep legacy code running, and then encourage people to move to the new nomenclature. But for some reason, they don't want to do that. I don't know why. So that does make it a little, awkward sometimes when you're trying to figure out what's going on. But most of them, luckily, are there. And as you notice, there's basically a renderer for every single element that's in, every single control, every single element that's in Xamarin.Forms. So I'm going to show you a demo now of some code to do this. Now, I just want to say, so what we're going to do is we're going to extend the box view control. So box views are really simple, but they can be really useful. But what would be really useful is if we had things like rounded corners, borders on them, we could put shadows on them. Now, just as a note, this demo is actually based on one created by Mark Smith from Xamarin. It's actually, it's been updated. It supports Windows as well, and it's corrected some of the bugs that are in his version as well. I hope he says that, and then it'll probably have bugs. So let's try. Try and share the screen across, extend the screen across both. Okay, around here because see it on there. Okay, sorry about that. So what we've got here is what we've done is created a project. This is a project with, it's a forms project with obviously our portable class library, a shared portable class library for the demo, an Android version of it, iOS and Windows Phone specific. So it's just using the standard template. And what we've done is we've created a custom element called extended box view. Now, the first thing we want to do is we're going to want to extend it, so we want to add some extra properties to it. So what we're going to do, first of all, is we're going to add a corner radius property to define the corner, the radius around the corners, a border, a thickness property for the border, and a color property for the border. Now, we could just use, standard getters and setters, but in Xamarin.Forms, you can use binding. You can use data behind the scenes. You use both the code level, code behind, or it could be used in your XAML. Using XAML is a really powerful feature. So it's almost like, why would you ever use just standard getters and setters? So the properties you're going to add, use the built-in bindable property. And this is how you do it. So you basically create a bindable property. It's that statement at the top, public static read-only bindable property. The name of the property with the word property appended to the back. It's very important that you do that. If you call it anything else, it will actually create it will actually cause a runtime error. And then you basically tell it to create a bindable property. You tell it what the class is that is being created in, and what the value of that property is going to be, what class it's going to be. So in this case, corner radius is a double. And then you tell it, you give it basically a link queue, anonymous method to tell it which property it's going to basically relate to, and a default value for that. Now, there's actually about 5 or 6 different versions of this, different versions of how you can create a bindable property. This is pretty much one of the most useful ones. There is one that allows you to actually get it to other things as well. So there's 2 that tend to get used more than that, but more than any others. This is one of them. And then you create the property. And the property is great. You create your getter and setter, as normal. But instead of just, storing it in the private value, what you're doing, you're setting it in this bindable property, and you're reading it in the bindable property. Now, bindable property just stores an object. So when it reads out, you actually get an object. So you need to cast it to the correct type. But when you're setting it, you don't have to, because it just gets set into the object. And so we're going to do that. We've done that for each of those properties. And then that's all we're doing, because we're actually inheriting here. We've decided to inherit from boxview. So this is going to do everything that boxview does, and just add these properties, nothing else. Now if we take a look at the custom renderer for this. So obviously we're in Visual Studio. I've only got the indie versions and then, so I don't have, I can't do Android or iOS in this. So we're just in here. We're just going to use the Windows Phone version. Controls. We're going to create our renderer, which is here. Okay, so one of the things you'll come across all the time with this, especially if you use, if you're doing any Windows Phone stuff, is you'll have the same names associated with Forms components and Windows components, and sometimes other native components. So in this case, instead of having to put everything else, I've just put these using statements up here for Windows Phone color, Windows Phone grid, and Windows Phone rectangle, to get just so I don't have to keep putting everything in there all the time. So we're creating a class, an extended boxview renderer, and we're going to inherit from boxview renderer. In the case it's Windows Phone, the renderer for boxview in Windows Phone is boxview renderer. So we're just going to inherit from that. And then we're going to just override this onElementChanged method that that it exposes. First of all, we're going to call the base version of it, because remember, we're still using box view. We still want box view to draw, everything for box view to do to still happen correctly. So we're going to need to call the base version of it. Okay. And then what we're going to do is we're going to do our platform specific stuff. For Windows Phone, to get it to actually support the extra things you want to do. So in this case, as you can see, we're going to pull. First thing I'm doing is pulling out that extended box view, that abstract element, using the element property. So I can get those properties, those extra properties that we have, I can pull out of that Xamarin.Forms control that we've created. So then we pull out the corner radius. Now, this control is exposed in box view, and control basically is a rectangle in this case. And you can see that if we hover over the control, you can see that it's a rectangle. So what box view does is it actually renders a box view in Windows Phone as a Windows Phone rectangle class, or a Silverlight rectangle class, or a WPF rectangle class. And it exposes that with the control property. So all we have to do in this case is set its radius, the X radius and Y radius, to be equal to the corner radius. And it should draw correctly. And similarly, we can set the border color as well. So we're going to pull the border color out of there, and then we're going to convert it into a color version for Windows Phone. Now, for iOS and Android, they built in those extension methods. They haven't for Windows Phone, so you have to do it yourself. But it's pretty easy. You just create it from the RGB values, the RGB and A values. So just pull it out and create your color class that Windows control can understand. Create a solid brush from it, and then set it to the rectangle stroke property. And then we'll set the stroke thickness to be equal to the thickness that we've created for in our class. And then that's all there is to it. However, we're also going to want to be able to change these properties. So what happens when one changes? We want to be able to bind to those values. Now, if we don't do anything with it, then if something changes, it will then get updated. But it gets updated through this on-element property change method. So we're going to override that. And again, what we're going to do is we're going to call the base version of it, because again, if something changes in the box view, we still want it to change. For example, if you change the color of the box view, we're going to want that to change, or the size of it. And then what we're going to do is we're going to go through, and what this does is this exposes this property change event args, and that has in it has a property called property name. And all that is a string that is exactly the same as the property name that the property you created. So we're going to test it. So we're basically going to say, hey, you call this, that's fine, and then we're going to test this name to see if it's one of the ones that we want to support. So in this case, we compare that property name to the extended box view corner radius property name for that. And if it is, we're basically going to pull out the element, and we're going to set the radius, the corner radius, to the new value of the corner radius. And we're going to do the same thing for the color, the border color, and the border thickness. And then that's all there is to it. So let's see what happens when we try and run this. Well, what has happened?
why Xamarin wouldn't have supported those properties in their version of that control?
No, I mean, it's been questioned as to why they haven't just put this in, these sort of things in anyway, but
Right.
they haven't, so. Stop this rebuilding. That's embarrassing. Oh, I know, I don't. I forgot to go and make sure that the Xamarin's put the correct page. Content page. Oh, that's a box. So let's look at this demo page. So what we're going to do here is, I go through the XAML as well, so I forgot to go through the XAML with you. So with the XAML, we're creating standard XAML for it, with the class in it. But we're also going to create this local control, this local namespace for our local controls. So in this case, the namespace is extended box u demo.controls, and it's going to be in this extended box u assembly. And then what we can do is we can actually reference our new extended box u using this local controls : extended box u, and then assign the values that we're supporting with it. And in this case, what we're also going to do is add some sliders and things so that we can actually use those and to change the values, and we're going to bind them to the values in the native control. We do that by, in this case, with the slider, using this binding context, and we reference this extended box u, which we've given a name. And then we're binding it to this corner radius property in this case, and we're saying it's mode one way to source. Now, what mode one way to source does is it allows you to say, here's a control that's going to affect the property in something else, and depending on the value in this control, it's going to push that value into that other control. you can also have binding one way, and if we were to do the binding in here, and in the control, we would use binding one way. The problem there is you can only bind to one. If you bind that way, you can only bind property to one thing. So you can't actually have multiple things affecting your properties. And you can do two-way as well, so that you can have it so that if the control gets updated by something else, it could update the value of the control that's the other control. So they didn't explain that very well, but sorry about that. We're going to build it. Let's rebuild solution and we'll try and.
Is that a XAML thing or just
That is Xamarin's version of XAML.
Oh.
Okay, that's better. So here we can see that we've now created, and that's for some reason, that's why it wasn't showing, it was showing as black. It should be blue for some reason, but it's weird.
Could be the projector.
Could be the projector. That's why it wasn't showing up before, because it was just a box view to show that it was working. So now we can change the corner radius. See it's changing, and the border thickness. Okay. So what if we want to do that and add a shadow to it? Well, actually, no. Let's look at the Android version first. So. So it's putting exactly the same code in. But this time you'll see that obviously iOS, because it's running on a PC, the iOS project's not available, and the Windows Phone project's not available. If we look at the extended box view, it's exactly the same. Exactly the same as before. Nothing's, in fact, it's exactly the same code in this case. It's exactly the same solution. It's exactly the same project that's being called, but I've got a different solution file for it. Let's take a look at the custom renderer for that. Okay. So in this case, what we're going to do is we actually have to we're going to be using this draw command. So if we look at, we're going to inherit from box renderer. And when we look in the box renderer class, the box renderer for Android, it doesn't expose that on element change method. What it does is expose this draw method. And the reason is that this actually inherits from the view element renderer class, whereas in Windows Phone, it inherits from the view class, the view renderer class. So one of the things that we have to do is that, so we actually sort of draw things at a lower level using this draw method, and we're going to override that. But in Android, in order to prevent multiple basically regression calling of the draw method, it basically turns off inside the Android runtime. It turns off access to the draw method. So even if you call it, it won't run. So we actually have to turn it back on again, and we do that by this set will not draw to false. So we'll put that in the extended box renderer constructor. Now notice we don't have to bother about what's actually in that box renderer, because we're actually going to draw this. We're going to basically do everything ourselves on the draw level. We're not being passed something that it's drawing. It's just exposing this draw method, so it's doing it at a much lower level. So again, we basically get the element, which is our abstract version again. And in this case for Android, we're just going to create a rectangle, a blue rectangle. And we're going to basically using this get drawing rect, because this is it's passed as a canvas and this is a view. It's basically going to, by doing this, we're actually going to set that rectangle to have the correct bounds for the parent that contains it. And what we're going to do is basically do two rectangles. We're going to do an outside rectangle, which is going to include that's going to represent the border, everything with the border, and then on top of it, we're going to draw the inside rectangle, which is the main color and everything that we want. So it's just going to be two rectangles on top of each other. So we create all we do is we create the inner one as well. We're going to inset it by the border thickness. So we're basically going to say, hey, it's this much, but we're going to make it smaller by the amount for the border thickness. And then we're basically going to create a paint. We're going to set anti-alias to true. And we're going to set the paint color because we're going to do the border first. So we're going to set the paint color to the border color. And notice that here we have this toAndroid extension method that's provided by the Forms SDK, the Forms namespace. Then basically on the canvas, we're going to tell it to draw a rectangle. We're going to tell it to draw this rectangle here with this corner, with the corner radius that's been passed to us. And then basically what that's done is it will draw a whole rectangle that fills up the entire parent and make it the color of the border. Then we're going to reset the color of the paint to the color of the main box and draw it again, this time using that inner rectangle, so it's going to be a slightly smaller rectangle. Again, we're going to need to change what happens when a property is changed. It exposes this on, because it's inherited from view element handler. It exposes this on element property change method. Again, we're going to call the base version, not that that really matters much, but we're going to, we're basically going to say if the corner radius changes, the border color changes, or the border thickness changes, we're going to invalidate the view. And what invalidate does in Android is it's going to cause that draw method to be called again. So it's just going to redraw it. Actually, we should also have here, dot color property name, because we're still going to want to support, although we're not sort of demoing it here, we still want to be able to support what happens if you change the color of the main box itself, which is part of the box. So we'd have to put that in. Remember, because it's not going to be doing that because we're drawing everything from scratch in this case. So let's just save that. Save all. Let's build it. Build all. And see what happens. Now we're using the same XAML. We're using exactly the same XAML. We're still calling demo page 1, which is exactly the same XAML as we had before. So it's it's the standard cross-platform stuff.
So how do you know when you're writing a custom render, you have to draw the thing yourself, like in this example, or whether you're in it a control and you just modify some of the properties of it, like in the previous example?
Good point. Now, in this case, we're actually inheriting from box view, and we're going to use it. We're inheriting from the box view renderer or the box renderer for each of the platform specifics. So you basically have to look at what those renderers are offering. Okay, now, in a moment, we're going to add shadows to this, and we're going to show what happens, at least in one case, what happens when you say, hey, we can't use that. We're going to have to use inherit from view rendering instead, and then you define what you're going to do. But in this case, unfortunately, there's almost no documentation on this. So there's nowhere that actually says, hey, here's a box view renderer, here's a box renderer, this is what it looks like in each of them, this is what it inherits from, this is what it looks like for each of the platforms. That documentation doesn't currently exist. So you have to do a bit of research yourself. You basically say, hey, I'll see what box view renderer does, and then take a look. And if you go to, go to declaration, it'll actually use the assembler browser and show you what methods and properties are available to you. Or you could use reflection if you wanted to get even more information out of them. I've got a little project going to try and do that. So what we're going to do is just run it. Okay, right, it is blue this time. So here we go. So this is it. This is it on the on Android, and we can change the corner radius like this, and the border thickness. So it's doing exactly the same thing in Android. And the same code, just the only differences are those two methods. Stop that. So let's take a look at what's going to happen if we want to add the shadows again. Well, that might be quite nice. So what we're going to do here is, first thing to do is to change the extended box view control that we've created. Well, so we're going to need to add some properties to this. That's it. There we go. So we're going to add a few more properties to this. The first one we're going to do is a Boolean, which is hash shadow, because we want to be able to turn the shadow on and off. And we're going to add a shadow position, so that we can actually change, how far out the shadow is from the main thing. And then we're going to add a shadow color property. Now we could just set it to black, but the problem is that on things like Windows Phone, the background's going to be a black background, so we're going to want to probably have it as a different color. So that's all we're doing. There's nothing else. We're just adding properties in there. Everything else we just still inheriting from box view. And obviously, we're going to have to update the custom renderer, our Windows Phone custom renderer, our extended box view control to support this. Now, the problem here is with rectangle in Windows Phone, it doesn't support that sort of thing. It doesn't support having a shadow that you can change the color of and you can move it and that sort of thing. Rectangle doesn't support that. So we're going to have to take a slightly different way of doing it. And in this case, what we're going to do is we're going to rewrite our custom renderer. And we're going to rewrite it as a view renderer. So now instead of inheriting from box view renderer, we're going to inherit from view renderer directly. And we're going to tell it, when you do that, you have to tell it two things. You have to tell it the class informs that it's going to be rendering, so it knows what it's being poured into in terms of an element. And you have to tell it what type of control it's creating, so it knows what the native control is going to be. So in this case, I mean, you could do this sort of thing in a number of ways. You know, there's many ways to implement something, but what I've done is I've done it as a grid, a Windows Phone or WPF grid. Now, the view renderer exposes this on element change method, and that's what we're going to override, because that's what gets called when it actually first tries to draw and create the platform-specific version. And we're going to call the base, you always call the base version of it, to basically make sure everything is okay. We are going to pull out the element, so elements exposed, so we're going to pull out our extended box view class, so that we can actually, so it can expose the properties that we want to set. Then we're going to do some color conversions. We're going to basically convert the box color and the border color into Windows Phone colors. Again, there's no extension method to use, so we're going to have to do that ourselves, as we did before. Then we're going to set up a parent grid. So we're just going to set up a grid. Now, in Windows Phone, the way that the native, when you set up a grid, the way that the grid interacts with the Xamarin.Forms layout means that it will automatically be given the size of the parent view that's containing it. So we don't have to worry about that. The grid will try and fill up the entire parent view. And then implement the layout options that we actually put on it. Now, the default in Forms is fill, so it will try and fill everything. But you can put start, you can put center, you can tell it to put it at the end. And what we're going to do now is we're going to basically do two rectangles again overlaying each other. One for the set, one for is going to represent the shadow, and then on top of that we're going to draw a rectangle that's going to be the main box view. So first of all, let's create the main rectangle. So we just create a rectangle, tell it to fill it with the color that we've just got out of our control, the border color with a border thickness and the corner radiuses. So basically we're doing what we did before, but we're doing a little bit more manually. We're doing it from scratch. We're looking at, by the way, we have to compile it first for that to go away. Now we're going to look at the has shadow boolean. We can say, well, if it has a shadow, let's create the shadow rectangle. And if we go to create shadow, I've just separated that out. Create shadow, all that shadow is we're pulling out the shadow color. We're making the width of the shadow. We're pulling out the shadow width. Sorry, excuse me. I've done a little calculation here to basically do a default, but we won't be using that. And then basically what we're going to do is we're going to create a rectangle for the shadow. And it's basically the same. It's going to have a fill. We're going to fill it with a solid brush of the shadow color. We're going to set the stroke to be the shadow color because we don't want it to have a border. We want it to include space for the border if there's any space differences. And the border thickness. Set up the corner radius to be exactly the same. And then what we're going to do is we're going to use this render transform property, which basically in this case tells it to translate, to basically shift it by the position, the amount that we've said to move the shadow out by. And then we're going to add this new rectangle to the grid, because that's going to be the first one. Now, what grid does is if you don't define columns and rows, it basically says, hey, you're going to have a single cell in there, and it's going to be the cell property is going to be star, which means I will try and fill up the area that's allocated to me. So we don't have to actually, in this case, create. We could actually say, row definition, column definition, one row with element star, one column with element star, and assign it directly to it. But there's a shortcut. We don't have to do it in this case because we're only going to have one cell in there. And then after we've added that, whether we have a shadow or not, we want to actually add onto the grid. We want to add the main box, the main rectangle that's going to represent the main box. And then we use this method here called set native control. Now, set native control is doing exactly that. Saying, hey, you've created this native control, and I'm now going to set it to be what's going to be rendered, what's actually going to be drawn on the screen. Now, we're also going to still have to handle what happens when some of these properties change. But this time, we're going to have to do things a little bit more manually. Because we can't rely, it's not just a case, it's not a draw method that's getting called. Now, we're having to create everything by scratch. So what we have to do is, again, we're going to go look at the property name and see if it's one of the ones that we're going to handle. But in this time, what we can do is we can put out the control. This control, this native control property, is exposed. So we can just pull that out and say, hey, we'll change these values on it. So in this case, we're looking at the color property. Now, this is the property of the main rectangle. So we're going to pull that out. We can pull out the control. We look at the children of it, and we happen to know that it's actually going to be it's either going to be at 0 or it's going to be at 1, depending on whether there's a shadow. But we know that it's actually going to be the last one. So what we do is we can just pull out the count, the number of children there are in there, take one away from it, and that's going to be our main box, our main rectangle. And we're just going to set the fill to the new color. And similarly, the corner radius property. We can do the same with the corner radius property. If there's a shadow, in which case if the count is going to be greater than if the index of, in this case, basically the count's more than 1, there's going to be a shadow. And we'll set the shadow rectangle of the shadow rectangle as well. We'll just pull it out of this control.children, pull it out, and do that. And we basically do that for the border color property, the border thickness property. It's basically doing the same thing for each one. Has shadow, what we're doing for has shadow, what we're going to do is either, if it has a shadow, we're going to add a shadow in, calling this create shadow method that we'll get to and pull it out. Or if it doesn't have a shadow, we're going to look to see if there's one already in there. If it is, and there should be one, we're going to remove it from the grid. So we're going to remove that chart from the grid, so it should disappear. And similarly, we're going to use the same things to change the shadow color property and the shadow position. So we're basically using the same thing. We're just having to do the same code several times through there. The last thing we're going to need to do is we're going to have to update the page that's being referenced. Now, in this case, what we're going to do is I've got another page here. Not here, we've just added a few things in there, extended box view, pretty much the same. But what I've done here is I've added a shadow color. I've added a different color depending on which platform it is. And then down here, I've added some sliders, a switch to turn the shadow on and off, and some sliders to represent the position of the shadow. And that's it.
Can you go back to the color card?
So in here, in the Xamarin?
Yeah. You said you were setting the color based on the platform?
Yeah, so in iOS, because native, because I'm not bothering setting up the page background color and all that sort of thing, and doing things using the native thing. In iOS, it's going to render something that's white background. In Windows Phone and Android, it's going to be a black background. So I just want to set something that will be visible. If it it was set to black for everything, you wouldn't be able to see it. And the last thing is in here, instead of calling that demo page 1, we're going to call this demo page 2. XAML. Save everything. Let's rebuild it. Let's run it. Fingers crossed. Okay. It must have been a connection as to why the blue wasn't coming out. So now we can see we have these extra controls down here. We have a switch for shadow and the shadow position. If you notice in this, XAML, we bound it to this switch. We've bound this to this switch to the hash shadow property, and we've bound this slider to the shadow position property. So now, if we do the corner radius, you see that still behaves exactly the same as it did before. No problems there. Oh, hang on a minute. What's happened? Something just stop this. I have forgotten to add something in. Oh, I know where I forgot to add it in. See? So everything works, but this shadow isn't working. Why isn't that shadow working well? It's because region. For some reason it's displaying it as black. Oh, I know why. I know exactly why. Okay, I did this before. So something that I didn't mention, which I should have mentioned before, and I forgot, was the fact that in order to link the custom renderer to the Xamarin.Forms control that you created, your custom control in Xamarin.Forms, you need to register it. And you do it through this line here. You do it as an assembly instruction where you tell it to export the renderer, you tell it the type of the renderer, and the type of the original view that you're linking to, and the type of the renderer. So I haven't changed this. It's still linking to the original renderer. So it's still doing. So it's not currently calling the renderer that supports shadow. It's calling that original one. So obviously it's never going to draw the shadow. It's going to ignore everything. One of the nice things about XAML is even though those properties are there, the renderer is going to ignore them because it doesn't support them. So if I change this, I call it extended box renderer 1. So let's add a 1 in there. Save that. Rebuild it. It will now call our new renderer, our new custom renderer, which supports the shadow. There we go. Let's run it. Now that declaration has to happen, you have to declare it before the namespace. And traditionally the way Xamarin has suggested you do it is you actually do it before the namespace in the renderer. But actually you don't have to do it there. You can actually do it anywhere, almost anywhere so you can actually declare all your renderers, custom renderers, in one place if you wanted to. Oh, why is it not running? Come on. There we go. So, it's changing those correctly. Now here we go. Now we get our shadow because we're calling our new custom renderer. And we can see that we can change the position of it, where it's, because we're just translating, it's quite a simple thing. You could translate, you could do it, so for example, you could shift it left and right, and you could put those extra properties in if you wanted. We can turn it off, we can turn it on, and it changes, along with the other properties that we've got. So that's it for Windows Phone. Let's take a look at the Android version. So let's see what we have to do for Android. Well, we've already changed our control class. We've already changed our examples. The only thing we should have to do here is change our custom renderer. Here we go. So in this case, with Android, we don't actually need to do the view class. We can actually just use what we've already got. We can actually do it through the draw. And that's what we're going to do. That's better. So the first thing we're going to do in here is we are going to add something in to handle it has a shadow. And what we're going to do is say if it has a shadow, we're going to set another paint color to be the shadow. We're going to offset it, so we're basically going to tell it, this one we're just going to offset it by a certain amount, which is the same as that translation in Windows. It's effectively the equivalent. Notice we can just use this to Android color conversion, and then we're going to tell it to draw that rectangle on the canvas. And we're going to do that before we do our main one. So basically doing exactly the same thing, two rectangles, one on top of the other. In this case, because we're handling the canvas in the box we read for Android, we can just use the canvas that's been passed to us. We don't have to use a separate. We don't have to use create a brand new renderer. So that's all it takes in there, and then all it really takes in here is we're going to have to handle what happens when those properties change. Now, because we're using the draw method, we don't have to do anything. We just have to invalidate it again, and it will just be called the draw method. So that's nice and simple. So let's just save all of that. Let's rebuild. And then we'll run it. And we'll see exactly the same thing. Just having this new emulator doesn't, of course, make the build process any faster. And here we go. We've got the same thing again, but this time, you can see that works fine. And we can see we can turn the shadow on and off. We can move the shadow position. Again, We've used a silver color for it. And everything moves with it just as before. So now we've got two custom renderers, one for Android, one for Windows Phone that supports these additional features. Everything else is the same. The control's the same, the Xamarin we're using is the same. So we now have actually extended that. And again, we can do it for iOS. Now I could show you that, but I'm not going to because it will go on and on and on. And that is one of the issues when you do this. Like, okay, now I'm going to do this for one platform, then the other platform, then the other platform, and so things do take longer. And you can see from what we did for the two custom renderers, you know, you can't, you still have to understand how the platforms are actually rendering and drawing these controls within their ecosystems. So you can't delegate that to forms. You're basically not getting that anymore. They're not doing that for you. But you can pretty much see, well, now you can use this in pretty much, you know, you can create almost anything you want, extend anything, create your own versions of things. And there you go. Now, if we were to look at the iOS version, okay, we would have actually done it using layers. So we'd have done it with the we could have for just the rounded edges and everything, we could have used the box view renderer and just inherited from that and told it to set those values. Again, someone mentioned why Xamarin just didn't do that anyway as part of their standard renderers and their standard box view. I don't know, but they didn't, because all the platforms support it. But for Shadow, again, we've run into the same issue as Windows, as with Windows Phone. We wouldn't be able to add a shadow. When you try and do that in iOS, it screws everything up. So you basically have to create your own renderer, you base it on your layer view, and you would actually create layers. So effectively, you're doing the same thing. You're creating two things that you're drawing. In fact, what you could do is you could actually have one which is going to be your main one, and add it to a UI view as a layer, and then the main view basically as a child, and have a layer there, and then in the layer for the UI view that's going to contain it, you could just set the shadow on that, and that's how you could do that. Now, if we were to do that, you would actually see that this shadow in there actually, instead of being solid, is sort of nice and it sort of fades out. So it actually goes from being solid in the center to sort of fading out as you go. So we could have simulated it a little bit here by putting the transparency so that it wasn't completely solid. You can still see something slightly underneath. But in iOS, what they do, and they sometimes call it a glow, I've heard it being called a glow effect, is because it has this sort of graduated transparency, where it's solid in the very center and it's more transparent towards the edges. It sort of gives this glow effect. And that's their native way of doing shadows, because you're just playing add a shadow to it. If you wanted to do that in Android and Windows Phone, they don't support that idea naturally. You would actually have to do something like create a bitmap that would do it, and do your shadow instead of a solid rectangle, do it by adding a bitmap. And setting the color with the bitmap and manipulating a bitmap and maybe with a mask or something in order to create that sort of effect. So you can see you can do all sorts of different things depending on what effects you want to create. But it's very dependent on the platform that you're doing it for as to how you can achieve it. So let's just go back to the So just finishing up, a couple of notes. Finish up with, if you create a library, so one thing to note is if you're going to create a library of components that include custom renderers, and generally speaking, that's what you would end up doing. You'll need to call something in the library before a call to forms.init. Now the reason for this is that when you do that assembly, or when you link it together, it can only link things. What happens is that linking is actually done as part of the runtime when your app first loads. And it can only do it for things that are in memory, that can't be in memory. So if that library hasn't loaded into memory, then it won't be able to make that association, and you'll find that it doesn't call your vendor at all. So generally speaking, what happens with those sort of libraries, you'll have a dummy call, a static method that's called, you know, a constructor, a static method called forms.init, which does nothing. What it actually does is it forces, a call to that forces that library to be loaded into memory, so that when you actually then, when you actually load, when it goes through, it's loading those associations, those registrations, it can actually see it and make those associations correctly. And you could do it by a number of ways, it's just that's the easiest, and this has become the really traditional way of doing it now. Another thing to note is that although Xamarin have exposed various renderers to you guys, to us, they haven't really made them easy to use. As you saw, there's no documentation. You know, where do you find out what, you know, what methods are actually exposed? Well, you sort of have to do it yourself. There's no documentation that tells you this and what properties. Many of the properties and methods that you might want to get hold of and might want to be able to look at still remain private. So you can't actually access them, you can't call them, you can't override that behavior. There's very limited documentation on them. In fact, until recently, there wasn't even an official list of accessible renderers. Actually, I created that list by basically using reflection and basically getting a list of everything that was in there. And it's actually all the private ones, and it's just a much bigger list. You know, so they didn't have that, let alone the exposed properties, the methods, and that sort of thing. Okay. Now, there is a new set of documentation available. I think it came out 2 or 3 days ago. It came out this week. And it can be found there. You can look it up, development.xamarin.com, guides, cross-platform, Xamarin.Forms, custom renderer. If you look up, if you do a search for custom renderer documentation, it'll probably bring it up. It's also in the developer forums. There's a couple of references to it. But that's new this week. And there's some reasonably useful information in there. It's much more than there has previously been available. It's still not, and it's still pretty sparse, but at least it's something. And one of the nice things in there is they've actually shown which controls and layouts and pages that they have in Forms use which renderers that are exposed to you. So that's nice. So you can actually see exactly, some of them are obvious, but some of them aren't. You know, especially when you look at some of the layouts, you know, what's a stack layout using, what's a particular page using. You know, that can be quite useful to see how they're doing that. But at least it gives you clues as to how they're doing it. Another problem is that when you're looking for examples, they're very simplistic. This here is probably the most complex example you're going to see that's out there. I say it's based on one that Xamarin did, which is very nice of them. I extended it a bit, added a few extra properties in, and did it for Windows Phone as well. And the one they actually have, if you look up the video, it's actually, although it works, it's using an old version of Forms, and it actually won't even compile. If you actually copy that code, it wouldn't even compile on the latest version of Forms, or the latest version of Xamarin.iOS and Xamarin.Android, because there's actually some mistakes in there. They've changed the version of Mono. Xamarin Android and Xamarin iOS have changed because they've incorporated some of the Mono features into Mono. They've incorporated some of the features out of .NET now. So a few things have changed, and it's broken a few things. And then there are some bugs and limitations for certain, which in certain use cases require workarounds. In particular, in Android, it can be very difficult to get the size of a parent, the way that they do the layout. It's very difficult to size things to your parent container. You know, in Android, often you want to do things like, hey, you know, just expand it to fit like the parent. It doesn't really do that very well in Android. It's difficult to do that. In iOS, if you're using a UI view, you can get the bounds, and normally you pull that in as part of the project. But in Android, it's a problem. In Windows Phone, it can be a problem. And then just a summary. So custom renderers are very powerful. They're going to allow almost any platform-specific element or feature to be utilized in forms. You create a new Xamarin.Forms control, and you can inherit from it, and you do that by inheriting from an existing controller visual element or your own, inherit from view or something like that. You then add your Xamarin.Forms PCL or add to your Xamarin.Forms PCL or share project. You create a platform-specific renderer for each platform. You inherit, to do that, you can inherit from an existing renderer if you enhance it, or you inherit from view renderer, or possibly view element renderer, create your own. And then you need to associate each of the renderers to the control, or each of the renderers to the element via this export renderer second-level attribute. And bear in mind that if you contain it in a reusable library, then you need to ensure that it's been loaded into memory before when it's loaded. So you need to do a call to something in there, like a dummy call into that library before the forms are in it, or the forms are in it to initialize forms. And there you go. That's it. So any questions?
Do you see any big upgrades coming to Xamarin.Forms soon, like 2.0, where a lot of these things might be easier, better documented?
Yes, I think there will. We might know more. Leo probably knows a little bit more about that. Whether he can say anything or not, I don't know. But for the first time, I saw Jason Smith actually talk about and saying this is what's in it, but actually mentions Forms 2.0 on one of the forums recently. He said, we're going to look at that for Forms 2.0. That's the first time I've ever seen him actually admit that there's going to be a Forms 2.0, which is going to be a major step forward. My guess is when that happens, it will break quite a lot in Forms. I know that he doesn't like the layout. I know in Android, the layout algorithms and mechanisms they use in Android are a mess. Real problem. I know that he really would like to change those. So I'm guessing that yes, it will be. When that happens, I don't know. Hey, maybe it'll be announced involved. That would be good. And I'm sure that there will be some major improvements at that point. They have been working on some improvements with performance. The latest pre-release of Forms, they've changed the way this view is done. They actually now do cell recycling in list views, which is like, why the hell would you have done that to begin with? It's sort of 101 of lists, but they finally put it in. There are some issues with it. There's actually, if you're actually looking at that sort of thing, having problem cells, there's a guy called, what's his name? Chris something. Pull it up. Here we go. George Cook has created a thing called fast cell, which is a way of doing view cells in XAML, and it basically builds in recycling. From what I can see, and I haven't dug into the new version, it looks like the new version still isn't going to be quite as efficient and effective as George's fast cell pattern. And he's also built in virtualizing the list as well. So he's actually built in a way to not only do cell recycling and not recalling the layout methods when you're using XAML to define the cells and bind properties to it. But he's also built into it the idea of having infinite lists. You only load in the data and the properties that you need as you're scrolling through the list, and you can drop them off the other end. So you can be effectively recycling. You're caching the data that's driving your cells via an enumerable list, and then and observable list, and then you're getting rid of it again, whereas you don't need it. So that's quite an interesting query if you look up. George Cook. But they are making improvements.
What about support for Windows 10 Universal API? Is that coming soon?
It's just come out. It's come out again in a pre-release version. They admit they're not just admit, they're very open to the fact that it's not finished yet. It's very much an alpha or even pre-alpha version at the moment. It's available, but they are fully expecting the community to report lots of problems and bugs with it. They hope to, they don't have a date yet as to when the final version will be ready. It depends on how many bugs they have.
That's part of the new version of Xamarin.Forms. That's pre-release.
I don't think it's that pre. It's another pre-release, isn't it?
It's separate.
It's a separate. It's a separate.
This is totally.
Yeah, and it's not on a public.
Yeah. It'll eventually it'll be integrated and replace the Windows 8 stuff.
Yeah.
But they're working on that kind of separately from. There's like Forms today and then the Windows 10 stuff. That'll eventually come up. Right.
Yeah.
Who knows? Yeah. However long it takes to get.
I wouldn't be surprised that they will try. I wouldn't be surprised if they try and coordinate that being available with a major upgrade to Forms. That would be a pretty logical thing. Because it's going to break quite a lot anyway, so why not do it all at once? Anyway, sorry about some of the things I couldn't duplicate, so it was coming out again to see. Any other questions? So don't be afraid of custom language. That's my big message, I guess. It's not. Oh, one little tip as well. Sometimes people say, well, the problem with forms is sometimes I have pages. I can't do them in forms. I have to do it natively, so it's pointless using forms. Well, you could still do a custom render for that and just associate it with the content page. And say, hey, content page, this content, instead of having content page, it's going to be, my page number 3, which inherits from content page, and then the custom render for that is inherits from view, a view render, and the view for that content page is just your custom render, or you inherit from page render, and you do it as you do it that way. And as I say, other than things like if you're trying to want to use fragments and things in Android, pretty much do anything by doing that.
That's exactly what I've done for Xamarin. So I have an infinitely scrolling list, and we build it all as a custom render.
Yeah. But as you do this, my recommendation anyway would be to create libraries of things, because you'll find that a lot of what you do with something is going to come up, you're going to need it again and again and again. Hey, well, I need that, I just need to add something to it. So you can just evolve your own, your own custom components, support the different features. So Mike, have you got anything to add about custom renders and forms and your experience with it?
I think big. I mean, just probably the big thing is be prepared to do a lot of platform-specific stuff. Like you can't get away from it. So knowing how Android and iOS and Windows Phone work is going to be essential to it. You can't, just because you're using forms doesn't mean you're not away from doing platform stuff.
Yeah,
this is kind of the big takeaway. Be prepared.
We had just started a new product a couple months ago. I did a big sit down with UX and product people to make sure everyone was on the same page to decide whether to use forms at all. Because we started looking at some of the UX concepts. We're like, all right, we got to get on the same page here. Either we got to stick to one theme for our platforms, or we just got to finish this forms thing. Because the had us doing express language pretty much every single, it just wouldn't have worked, so we're about to ditch forms until.
Right.
And that
Absolutely,
you're absolutely right. I mean, that's one, and it's, to me, it's actually one of the major benefits of forms, is that at the moment you have UX teams that are, it's the Wild West, they're allowed to go out and do whatever they want. So, you have you have your app, you have your product, and your experience of your platforms is different. Not only is the experience very different, but often the features and functionality supported by the platforms are different. They're out of sync, and they can go down rabbit holes on the different platforms. And that happens a lot, even with, very established companies and very established products. I think one of the powers and one of the nice things about forms is it prevents you from doing that. I mean, you really have to get your UX designers of different platforms in one room and say, what does this product want to do? What's it going to look like? You can do a certain amount of customization, but essentially the experience needs to be pretty much the same across the platforms. To me, that's a good thing. I think from a product management perspective, that's a good thing. The features are going to have to be, they're going to be the same on all the platforms. That's a good thing, but it takes discipline. And unfortunately, the way things are in a lot of, in our industry, is the UX guys have never had to really, have any discipline when it comes to making sure that the product is going to look like across the platforms. So they probably got a black bag, I guess.
Frankly, they're a little handicapped if they're just limited to Xamarin.Forms controls.
Well, you can still do custom renders.
Right.
But the thing is, you still want to say, well, what's it supposed to do? What's the flow? What's the workflow? What's the user flow in a use case? They've got to be similar on all the platforms. They should be similar on all the platforms if you want a unified experience across them. At the moment, often you don't see that.
It actually helped in our case. It really helped our product and UX people actually hammer out what we need to do in terms of requirements. Just send them a list of these are the Xamarin.Forms controls. UX person, can you put in terms of this? Before they were just text boxes. There's a search bar over here and something's flowing over there.
Were they successful?
Yeah, our UX person went through it and she said, okay, then redesign it, make it a lot simpler and easier to actually figure out what the hell it's supposed to do. It's like, okay, this is the page that does this. This is the page that does that.
So you're doing it on forms and not
We have one customer group right now for video, which is mandatory. I think it's not on their Xamarin documentation. It's a pre-time form post. And we're doing one for a custom toolbar renderer, like a tab bar at the bottom. That's about it. So far.
Yeah.
We'll see.
The nice thing about those things, there's some things in forms that make, but if you use forms, the fact that you can basically use data binding, and you can use some of the power of .NET that comes with that. Some things that are actually quite difficult in the native platform become very, very easy. Things like setting up filters, and search bars and things like this. You can use LinkQ to basically just 3 lines, and suddenly you have, you have your list or your data. You have a search bar. You can start putting things, and the list can automatically update itself. It took you 2 or 3 lines of code to create that. Whereas if you do it natively, that can be, obviously Windows Phone can do it because it's got the, use of the .NET framework. But in Android and iOS, things like that can be pretty difficult.
Doing a hamburger menu on iOS with forms is like one thing. Once you try to do it native,
It'll work around.
right?
And the fact for iOS,
you can't use it.
it's object-oriented. C# is object-oriented. iOS, Objective-C is not object-oriented. Not really. It's sort of like a mission. It's sort of like an early version of C++. You've got pointers all over the place. Dressing and things that don't belong in objects. So anyway, I'm a big fan of forms. I think custom renders has, there are some issues with it, and the biggest being that, there's very little documentation on it, and examples, be a lot of sporadic, but you can create some there are some apps out there that use forms that create some very, very effective changes. Okay, guys, thank you very much. We're still trying to sort out what we're going to do, as Mike said, for November and December. We'll probably do a joint one, a single one for November and December, because when we normally have it in November, it's Thanksgiving, and then we're into the Christmas period, so we'll probably do one. But we do have a favour to ask you guys. Think about some of the topics that you like covered. Because at the moment we're sort of dreaming up topics, and it's like, well, we think that people might be interested in this or in something like this, but it would be really good to get some feedback from people say, hey, I'm doing that, or something like that. Let's make this or this. Help directors. And then maybe as well we can reach out to other people and say, hey, not necessarily you guys, like, I want to learn about this, but then we might find someone that's willing to talk about that. That would be really useful. Thanks, guys. Yeah, so it wasn't quite as smooth as I would like. A couple of technical difficulties.
It's on a live presentation that something doesn't go wrong. It's always going to happen.
Thanks, David.
No, my pleasure, my pleasure. Oh, now it's decided to bring up the gems.